We often face many problems in our lives, most of which are ones that we can't see. But what about problems that we can't see? To fix these problems, we need little things. This is where we turn to our friend, the nanoparticles.
More specifically, carbon nanotubes.
I'm Hank Green, and
What are you doing? You're not Hank Green.
are you sure?
Yes, I'm pretty sure. You're not Hank.
Guys, stop arguing. We need to get back to the episode.
Hi, I'm Treyvon James.
Shane McGoldrick.
I'm Keely Billiar.
And I'm Megan Flockhart, and this is our unofficial crash course video about the ins and outs of carbon-based nanoparticles.
These little guys were discovered in 1991 by Sumio Iijima of the NEC Corporation of Japan. But upon further research, Mark Monthrow and Vladimir L. Kuznetsov found the origin of the carbon nanotubes may have been prehistoric.
Wait, you mean to tell me these are older than dinosaurs?
Yes, Panamarchuk et al. Has recently reported that they found carbon nanotubes in igneous rocks that formed over 250 million years ago. Along with this, the evidence of naturally occurring fullerenes in coal, carbonaceous rocks, and interstellar mediums imply that CNTs may form in natural hydrothermal environments.
That's so cool, but aren't carbon nanotubes just carbon?
Well, kind of. Carbon nanotubes have an electron configuration of He2S2 2p2, and they're rolled up sheets of single-layered carbon atoms, which is also known as graphene, which has a flat honeycomb pattern, making it the strongest material in the world. Also, these nanotubes have a diameter of less than 1 nanometer long, and they're multi-walled with several interleaved nanotubes with diameters reaching more than 100 nanometers.
Carbon nanotubes are also 400 times stronger than steel, lightweight, and thinner than a strand of hair. And when water is put into them, it can freeze even at temperatures that would normally boil.
That's right, and they are better thermal conductors than diamonds, along with having the capability of conducting electricity.
Wow, there really is more to them than just being carbon.
Since we know that carbon nanotubes are nanometers in diameter, that must mean that they heat up at low temperatures, right?
Actually, no. Despite their small size, these mighty little things have incredibly high melting and boiling points, reaching 3,500 degrees Celsius.
That's only 2,000 degrees cooler than the sun. But that's besides the point. Anyways, we discussed that they can be made in nature, but they can also be made in labs.
Well, not quite like that.
Common techniques used to create carbon nanotubes are arc discharge and chemical vapor deposition, while other less common techniques used to create carbon nanotubes include electrolysis and laser ablation.
These different techniques will each result in a different type of nanotube. Nanotubes hold many benefits to society because they can do many different things, from electron field emitters to automotive parts to textiles and sporting goods. The options are limitless.
For example, have you guys heard about Vantablack?
No.
Well, it's this material made from vertically aligned carbon nanotubes that grew on a surface of chlorine-etched aluminum foil. But here's the catch. Vantablack absorbs 99.995% of all light, making it the blackest material on record.
So what would happen if I put it on this tinfoil ball?
Oh, that tinfoil ball would look like a black, flat, featureless void, even with your eyes right up to it.
So cool.
I've also heard that one research team used carbon nanoparticles to deliver drug infusions to a pig. They discovered that carbon nanoparticles could be used to deliver a variety of drugs to treat cancer.
Imagine all the lives that would be saved. It's cool to think that most of the work associated with carbon nanotubes is currently still in scientific research, specifically chemistry, biomedical engineering, and hardware science. But I'm wondering, what could be some future uses of carbon nanotubes?
Oh, I know one. Carbon nanotubes can be used to make bendable electronics that could eventually replace current electronics that are made from brittle materials. But as of currently, that would not be a cost-effective option.
Along with this, drug-sniffing dogs could be replaced with hybrid olfactory receptor proteins and carbon nanotube transistors. These are called bioelectric noses. These bioelectric noses would have a shelf life of several months, but there is still a lot of work that has to be done to make this a possibility.
There's also the possibility that these carbon nanotubes can be used to make the cables for a space elevator, but sadly this idea is still hypothetical.
Well, we know all this information about carbon nanotubes, but why should we care about them?
Without carbon nanotubes, we would not be as advanced in our everyday lives from a technological standpoint and a healthcare standpoint. With the use of them, we can make things lighter and stronger than they were before.
Carbon nanotubes also have a high capacity for bonding with heavy metals like uranium, which would allow for the possibility to use them as water purifiers.
Well, we know all the good things about carbon nanotubes, but what about the bad?
He's right. Although carbon nanotubes are pretty amazing little things, they do have some negative aspects to them.
For instance, they're not easily soluble in water, meaning if they do bond to these heavy metals in the environment, they could get transferred to humans. This could be detrimental to human health.
There is also some concern that they could be toxic because elements on their nanoscale behave differently than they do in their bulk form.
And as we do design systems on a nanoscale, we have developed the capability to design the structures of all materials, natural and synthetic, along with bringing new possibilities of the reconstruction of all materials. Such a change represents tremendous social and ethical questions.
I guess the real question is, how far can humans push the nanotechnology threshold? We may not know the answer to this question right now, but it could be fast approaching. Keep this in mind as you dive into the wonders of carbon nanotechnology.
Now here's an experiment you can do at home to make your own graphene.
Treyvon the science guy here, and today we are in our handy dandy lab to make a material stronger than diamond, better conductor than copper, and super flexible. And all of that with tape, paper, and a regular number 2 pencil. Now, this secret material known as graphene is actually made from the same stuff as in your pencil lead, graphite. And the only difference between it is graphene is 1 atom thick. And the shape of it, hexagonal lattice, gives it its super crazy properties. Now to do the experiment, all you have to do, take your paper and scribble on it really hard. And if you do that, you'll have lead looking like that on your paper. And all you have to do, take your tape and then put it over the lead and tear it off, and you'll get a layer of graphite. Now, if you take another piece of tape and you put it over that other piece and you tear it apart, you'll get an even thinner one. Now, if you repeat this over and over and over again, you'll get a lighter and lighter piece, but it'll be a thinner and thinner and thinner piece of graphite. And the more you do this, the closer you get to getting a piece of graphene. And you can actually get a piece of graphene if you repeat it enough times. That's about it. That's how you make the world's strongest material with pencil, paper, and tape. Now let's hear from Philip Bradford, an expert in nanotechnology.
How did you first learn about carbon nanotubes?
How did I first learn about carbon nanotubes? I've been working with carbon nanotubes for, let's see, how many years has it been now? I started working with carbon nanotubes in 2007, so it's been like 13 years.
Dang.
Is that right? No, 2005. I started working on carbon nanotubes in 2005, so 15 years.
Wow.
For my project for my master's degree, and I was working with a company that was making yarns out of carbon nanotubes. And so my research project was to study some of the mechanical properties of these new type of yarns that were made entirely of carbon nanotubes, which is kind of a cool application because it's a nanomaterial, and to be able to turn it into a textile-based yarn structure is pretty unique.
How do you, when you're conducting the experiments to make the graphene to make the carbon nanotubes, how is that done?
So we use a high temperature furnace in my lab. It's usually at about 750 degrees Celsius. What's the conversion? 750 C2F. 1382 degrees. So it's pretty hot. Hotter than your typical pizza oven or whatever, right? And so we use a high temperature furnace, and we use nanoparticles of iron to nucleate the nanotube growth. And then we introduce acetylene, which is a highly reactive carbon source gas, and it reacts with the iron particles to make the nanotube structures. And then after a few minutes, they're long enough to actually see, and then we cool it down and use our nanotubes that way.
I got a question. What current application are you guys working to go towards with your research?
So we use them in a lot of different things. The big ones right now that we're looking at are to make electronic and smart textiles.
Mhm.
So carbon nanotubes are electrically conductive. Not as good as metals, but they're pretty electrically conductive, but they're a lot more durable and they're a lot more inert. Metals have a problem with, like, if you try to make metal yarns for like smart clothing and stuff,
Oh yeah.
they break down in the washing machine because of the corrosion.
What would a smart clothing like electrical clothing?
Yeah, like smart textile. We call them smart textiles or e-textiles. Basically, textiles with sensing functions built in, that kind of thing.
Oh, cool.
You know, like everybody wears their like Fitbit now, right? It can sense your heartbeat and some other bioparameters. Like if you could put sensors in clothing, then you could do a lot more.
Cool.
Right? And so we're trying to make yarns that are conductive but are better than metal because they can stand washing and they can be a little bit more comfortable than like metal against your skin or whatever.
Wow, that's cool.
Yeah.
So there's a bunch of different like applications, but out of your experience, what do you think is going to be like the best one to help impact the world in a positive way?
Oh, that's a good question. I mean, a lot of the things that we're researching right now are, you know, they're not going to be in consumer goods tomorrow. And so we're trying to figure out, you know, where those applications lie. A lot of the stuff we're looking at is for military purposes. And so, you know, whenever you can make something useful for the military, it kind of is nice to think about supporting national defense and stuff like that. And then a lot of the things that we're working with the smart textiles, especially with other professors in the department, thinking about healthcare applications. So they're going to be expensive to put like sensors and stuff in your clothes. You're not going to like wear them every day, but for people that have critical health issues that, you know, need to have a garment like that, you know, it would be really valuable for their healthcare experience. So I think that would probably be one of the ones that would probably impact the people the most, you know, the most quickly.
And then, like, after you make the carbon nanotubes in the furnace and everything, how do you store them? Like, is it just a refrigerator or something?
No, they just store them in containers at room temperature. They're very stable.
Yeah, you guys make them like yarn, right?
We make them in yarn.
Okay, and that's just, you leave them how they are?
Yeah.
Cool.
Thank you for watching this unofficial episode of Crash Course Chemistry. If you were paying attention today, we talked about the wonders of carbon nanotechnology.
We discussed that carbon nanotubes are made of rolled up sheets of carbon atoms and they can be used for many different things.
While discussing the pros of this nanotechnology, we also acknowledge that they do have some cons.
We hope you enjoyed this week's episode. See you again next week.
Bye!